Likewise, a perpetuity immediate with varying annual payments. During the first 5 years, the payment is constant and equal to 10. Beginning in year 6, the payments start to increase for year 6 and all future years. Payment in the year is k% larger than the payment in the year immediately preceding that year, where k is less than 9.2. At an annual effective interest rate of 9.2%, the perpetuity has a present value of 167.50. Okay. So this is what's going on, and I drew a timeline, and we can keep on going. And we know right here the value is going to be just 167.5. Okay, great. So let's first take this geometric series and take it back to time 5. So we have 10, 1 plus k. Now we got to discount that. So divide by 1.092 because the interest rate is 9.2%. And then we have plus 10, 1 plus k squared, 1.092 squared. Okay, so we have, remember, the sum is just going to be first term over 1 minus common ratio. So I'm going to factor out actually a 10 over 1.092, and then I get 1 plus k plus 1 plus k over 1.092, so on and so forth. So I get 10 over 1.092 first term, 1 minus common ratio. Okay. Great. And that brings it back to time 5. And if I want to bring it back to time 0, I'm going to say times 1.092. And it's going to be to the negative 5 now. Okay, so now it's back to time 0. Great. And now I just have to take these series of 10, these 5 payments of 10 back to time 0. So this goes here, right? So on and so forth. So I could just do it in terms of annuity notation, but in case you don't know it, we don't have that many. We can say 10 divided by 1.092, right? Plus 10 divided by same thing squared, plus 10 divided by same thing cubed, right? Now we're here. So then we have plus 10 divided by same thing to the 4th, plus 10 divided by same thing to the 5th. Okay, so let's go ahead and figure out what that is in terms of just the tens. So 10 divided by 1.092. And you might want to store that in your calculator, okay? Squared plus 10 divided by 1.092 to the 3 plus 10 divided by 1.092 to the 4th plus 10 divided by 1.092 to the 5th. So we get 38.69, okay? $695, $696, and now that is equal to 167.5. So we get this, and what I'm going to do now is we definitely want to use our calculator. I'm going to say 167.5 minus 38.696 divided by 1.092 to the negative 5 times 1.092, and then divide that by 10. So we get something cool. We get this. We get 1 plus k all over 1 minus 1 plus k over 1.092 equals 21.84. And now we just have a slightly complicated linear equation. What I would do next is get a common denominator, 1 plus k over, so I have 1.092 over 1.092 minus 1 minus k over 1.092. So this ends up becoming 0.092 minus k all upon this, so it gets multiplied here. And that's equal to 21.84. Anyways, it's just algebra. I don't want to spend too much time on that. Just be careful. At this step, you could divide by 1.092 and just do some algebra. You're going to get, I got 0.04, and I made k a decimal, so it's going to be 4%. Okay.